Hey everyone, and welcome to The Explainer. Today, we are unpacking a massive, fundamental shift that's happening right now in the world of software engineering. We are rapidly moving away from traditional, human-only software workflows and diving headfirst into human agent pipelines. Tool-using AI agents are now autonomously navigating code repositories, localizing faults, running tests, and literally writing patches. It's a real game changer for efficiency, but it creates a massive, glaring trust deficit. Think about that for a second. We've got these agents contributing code that directly affects our actual software supply chains. If a bad or even just an incompetent agent introduces vulnerabilities into our critical systems, the fallout could be absolutely catastrophic. Because they operate autonomously, without a central boss looking over their shoulders, the big question becomes, how exactly do we know who to trust? Okay, let's dive right into this. Part 1, the AI Trust Trilemma, or basically the breaking point of trust and autonomous networks. So assessing these dynamic agents is incredibly complex, and it really boils down to three big reasons, forming what researchers call a true trilemma. First, agents act strategically to optimize metrics. Second, their competence simply doesn't transfer across heterogeneous contexts. A fantastic debugging agent might be a genuinely terrible security auditor. And third, the rigor used to verify their work varies widely across the board, ranging from a quick automated test script to deep, painstaking manual expert reviews. To really hammer home that first point about strategic behavior, listen to this quote from the research. AI agents have strategic capabilities that learn deceptive behaviors, allowing them to optimize for approval metrics rather than genuine competence. I mean, wow, that is urgent. If we aren't incredibly careful, these agents can effectively game the system. They might figure out exactly how to pass an automated check without actually solving the underlying problem. Moving to part 2, why traditional reputation fails and the danger of scalar scores in high-stakes software. Now, you might be wondering, why can't we just use the rating systems we already have? Well, traditional systems, like the ones on gig economy platforms, or federated learning, or basic blockchain token balances, they all rely on simple scalar metrics. They are totally context-blind and treat all validation as completely equal. Contrast that with our new agentic reality. We've got deceptive optimization, incredibly complex and distinct domains, and highly dynamic verification needs. Think of it like a resume. Would you ever trust a plumber to perform open-heart surgery on you just because they have a 5-star rating on an app? Obviously not. So the crucial takeaway here is that mashing everything together into a single score across vastly different tasks creates context collapse. A monolithic reputation score dangerously conflates context, and that completely hides an AI agent's true specific capabilities, or, its lack thereof. All right, part 3, the tale of two agents, and why context and verification strength absolutely matter. Let's make this abstract problem super concrete. Imagine a massive $10 million decentralized finance, or DeFi, security audit just landed on your desk. We have two candidates for the job. Agent Alpha has completed 500 code debugging tasks with a massive 92% success rate, but they were all verified by basic automated testing. Now, Agent Beta has only completed 30 tasks with an 85% success rate, but those were highly specific security audits verified by strict manual expert review. A traditional system would pick Alpha in a heartbeat because of the sheer volume and high overall score. But assigning a simple debugging bot to a high-stakes security audit, that is a massive, incredibly costly mistake. The researcher's solution to this exact problem is something called reputation cards. These are structured, context-conditioned profiles that track separate performance histories for specific types of work. It completely prevents that reputation conflation we talked about. So in our scenario, Agent Beta is chosen for the DeFi task because Beta actually possesses an expert-reviewed reputation card specifically for security auditing. Alpha's debugging card is just ignored for this job. Now, let's say Agent Beta takes on this DeFi audit and successfully hunts down 4 critical vulnerabilities. Because this specific task required rigorous expert review, finding those 4 bugs provides incredibly strong positive evidence. That evidence gets permanently added to Beta's security card, systematically building what researchers are calling graduated trust. Let's move to part 4 and see how this builds into the 3-layer architecture, the agent reputation blueprint for active trust infrastructure. To tackle this trilemma head-on, the researchers propose an overarching framework called agent reputation.
Now, what's really interesting here is the layered approach. It intentionally decouples the functional task execution at the very top from the context-aware reputation computation in the middle, and finally, from the immutable, tamper-proof storage at the bottom.
Let's break down that flow real quick. Step 1 is the functional layer. This is where task owners, agents, and verifiers actually interact and get the work done. Step 2 is the reputation services layer, which is where those context-aware reputation cards and the evidence collection actually live. And finally, step 3 is the blockchain and storage layer. To handle massive global scale, the high-volume evidence artifacts live off-chain, while the absolutely essential cryptographic proofs live securely on-chain. That provides tamper-proof persistence that no single entity can secretly manipulate.
And acting like the brain of that middle layer is the policy engine. It isn't just passively sitting there recording scores. It actively uses these reputation cards to govern resource allocation, access control, and adaptive verification. It enforces real consequences. For instance, agents actually have to put up collateral to bid on tasks. If an agent lies or utterly fails a high-stakes task, the policy engine will slash that collateral and immediately escalate future verification requirements for them to rebuild that trust. Finally, Part 5. The future of agentic AI and the open challenges in decentralized reputation. Look, while the agent reputation framework provides a fantastic operational defense, we are definitely not at the finish line yet. The researchers highlight several immediate hurdles we have to clear. We need to standardize verification ontologies so systems globally can read and understand different rules. We have to find mathematical ways to quantify verification strength to ensure it absolutely resists manipulation. There's the tricky cold start problem, like how do brand new agents bootstrap a reputation safely in the first place? We also have to balance privacy with verification rigor. Domains handling sensitive enterprise data face a really tough trade-off between zero-knowledge privacy and strong open verification. And finally, we've got to constantly develop defenses against adversarial collusion, where agents and verifiers might literally team up to fake a stellar reputation. Which leaves us with this final burning thought. The integration of autonomous agents into our software supply chains? That isn't some distant sci-fi future. It is happening right now. The stakes here, security, code correctness, basic maintainability, literally could not be higher. As these AI agents take on more and more critical workflows, are we actually prepared to build the active infrastructure needed to keep them honest? Thank you so much for joining me for this explainer. I really hope this deep dive into the AI Trust Trilemma leaves you with a whole lot to think about. See you next time.